Embedded Systems Engineer Job Role, Practical Experience Guideline and AI Contribution. Welcome to the world of embedded systems engineering, where software meets hardware to create the future of smart devices. Embedded systems engineers are at the heart of innovation, working on technologies that power everything from smart homes to autonomous vehicles. As an embedded systems engineer, you'll master the art of building and optimizing systems that are both powerful and also efficient. If you're ready to take on challenges as well as transform ideas into reality, this is the career path for you. Job description. An embedded systems engineer designs, develops and optimizes hardware-software systems that are integral to the operation of modern devices, from IoT gadgets to automotive electronics. Their work involves ensuring seamless integration between software and also hardware, focusing on reliability, performance, as well as scalability. Industry profile. Embedded systems are increasingly critical across sectors such as automotive, aerospace, healthcare, telecommunications and consumer electronics. With the rise of the Internet of Things, IoT, also smart devices, embedded engineers are in high demand to create innovative solutions that combine minimal power consumption with high performance. Key responsibilities. System design and development. Develop embedded systems and firmware for microcontrollers, also processors. Hardware-software integration. Ensure proper integration of software with hardware platforms. Real-time testing. Conduct tests for real-time performance as well as troubleshoot bottlenecks. Optimization. Optimize the embedded systems for power consumption, cost along with speed. Security implementation. Incorporate cybersecurity measures in embedded software. Documentation. Maintain comprehensive documentation for design processes and coding standards. Collaboration. Work with cross-functional teams in hardware design, product management, also software development. At a glance. Your interest. Passion for programming, electronics and system optimization. Entry qualification. Bachelor's degree in electrical engineering, computer engineering or related fields. Lifestyle. Fast-paced, requiring continuous learning to stay ahead of evolving technology. Location. Offices, R&D labs or remote work environments, opportunities in tech hubs. The realities. Work involves long hours, intense problem solving, also detailed debugging. Soft Skills Guide. Ability to collaborate effectively with cross-functional teams. Strong problem-solving skills and attention to detail. Excellent analytical thinking for troubleshooting complex systems. Leadership abilities to mentor junior engineers, also lead technical projects. Adaptability to continuous technological changes in hardware as well as software platforms. Career path. Trainee. Join a company or R&D lab as a trainee, focusing on foundational skills. Graduate engineer, work under senior engineers to gain hands-on experience. Firmware developer. Specialize in software for embedded platforms. Systems architect. Design system-level solutions for embedded devices. IoT specialist. Focus on IoT protocols and cloud integration. Senior embedded engineer. Led embedded system projects with extensive experience. Technical consultant. Provide consulting services on embedded solutions. Related careers. Firmware developer, focuses on writing low-level code for microcontrollers. IoT engineer, specializes in integrating embedded devices with IoT ecosystems. Cybersecurity engineer, ensures embedded devices remain secure from external threats. Systems architect, designs also structures complex embedded systems. Robotics engineer, develops robotics hardware and software, often using embedded platforms. Here's a list of essential practical experiences for an embedded systems engineer and ways to learn them using the latest tools and technologies. Microcontroller and microprocessor programming. Experience. Develop firmware for microcontrollers, e.g., Arduino, STM32, and microprocessors, e.g., Raspberry Pi. How to learn. Start with platforms like Arduino, also Raspberry Pi. Use online simulators, Tinkercad, for hands-on experience without hardware. Take courses on platforms like Coursera or Udemy covering ARM Cortex programming. Experiment with real-world projects such as smart lights or temperature sensors. Real-time operating systems, RTOS, development. Experience. Work with RTOS to manage time-sensitive tasks, e.g., FreeRTOS, VxWorks. How to learn. Use FreeRTOS on STM32 boards to gain practical experience. Enroll in specialized courses on platforms like Udacity or edX. Practice task scheduling, resource sharing and real-time debugging. Circuit design and PCB layout. Experience. Design schematics and PCBs, printed circuit boards, for embedded systems. How to learn. Use tools like KeyCAD, Altium Designer or Eagle CAD for PCB design. Participate in online tutorials and workshops on PCB design, also electronics. Design as well as build custom PCBs for small projects like IoT devices. Communication protocols, I2C, SPI, UART, CAN. Experience. Implement and debug communication between embedded devices. How to learn. Experiment with I2C, also SPI, using Arduino boards. Work on CAN protocols for automotive applications using CAN simulation tools. Follow protocol-specific courses on online platforms or attend workshops. Embedded C/C++ and Python programming. Experience. Write efficient and optimized code for hardware interaction. How to learn. Take courses on embedded C/C++ through Udemy or Pluralsight. Work on microcontroller projects using both C/C++ and Python. Participate in competitive programming challenges focused on low-level programming. Embedded Linux and device drivers development. Experience. Build custom Linux kernels and develop device drivers. How to learn. Set up Linux on Raspberry Pi or BeagleBone Black. Follow tutorials on building and cross-compiling Linux kernels. Learn device driver development through specialized courses on Udemy. IoT development and cloud integration. Experience. Design embedded IoT solutions and connect devices to cloud platforms, AWS IoT, Azure IoT. How to learn. Develop IoT prototypes with ESP32 boards, also connect them to cloud services. Take AWS IoT or Azure IoT certifications. Build practical projects such as remote weather stations or security cameras. Debugging and testing tools, JTAG, GDB, logic analyzers. Experience. Use tools for debugging and testing embedded hardware and software. How to learn. Learn GDB debugging for embedded applications. Experiment with logic analyzers for signal analysis. Use JTAG debuggers with development boards for hands-on experience. Cybersecurity for embedded systems. Experience. Implement security measures to prevent vulnerabilities. How to learn. Follow online cybersecurity courses with a focus on embedded systems. Implement encryption and authentication protocols on embedded platforms. Practice penetration testing on IoT devices to find vulnerabilities. Machine learning on embedded devices. Experience. Develop machine learning models and deploy them on edge devices. How to learn. Use TensorFlow Lite to deploy ML models on microcontrollers like Arduino Nano BLE Sense. Participate in Edge AI courses on Coursera or edX. Work on small ML-powered projects such as gesture recognition. Version control and project management, Git, Jira. Experience. Use version control and project management tools for collaborative development. How to learn. Practice using GitHub for version control, also collaborative projects. Take free courses on Git on Codecademy or LinkedIn Learning. Use Jira or Trello for managing embedded development tasks. Soft skills, collaboration and communication. Experience. Work effectively in multidisciplinary teams, especially when collaborating with hardware, software, and product teams. How to learn. Participate in open-source projects or hackathons to build teamwork skills. Take soft skills courses on Coursera focusing on communication, also leadership. By following these guidelines and using updated tools and technologies, you can build a well-rounded skill set that aligns with the latest demands in embedded systems engineering. 8. A contribution to autonomous transformation for embedded systems engineer role. Thank you for listening. For more information related to career path, job role, or description, follow our channel Career Quest.